Hi, and welcome back to Science 1206, the Sustainability of Ecosystems unit. I'm Ms. Ledwell, and in this video, we'll discuss populations and sustainability. Let's begin. First up, we're going to review the term population, which we discussed in a previous video. Recall that a group of individuals of the same species that can successfully reproduce, living together in one ecosystem at the same time, is called a population. The population of foxes in an ecosystem, for example, depends on a number of factors, such as food availability, the amount of competitors for food, the number of predators, and available den sites. So we can see from the image this is a population because they're all the same species, they're all foxes that can successfully reproduce offspring, and they live together in one ecosystem at the same time. Next, let's review the term niche, which we've also discussed previously. Recall that in an ecosystem, each organism has an ecological niche. A niche is defined as a role that is undertaken by an organism in an ecosystem. Different species can coexist in the same ecosystem because they occupy different niches. For example, the birds in the diagram live in the same area but occupy different niches. Their beaks are specialized, and they eat different types of food. Some eat insects, and others seeds and nuts. The birds with the long, narrow beaks, like number 4, are specialized to eat insects, while the ones with the broad, blunt beaks, like number 1, are specialized to eat nuts and seeds. An organism niche or role includes where it lives, what type of food it eats, how it obtains its food, and how the organism affects its environment. Now we're on to something new, which is the term equilibrium. When a population is in equilibrium, it is in a state of balance, in which there is no net change over time. In other words, the birth rate is about equal to the death rate, and the number of individuals that make up the population stays around the same. Exponential growth is the accelerated growth of a population that produces a J-shaped curve like you see in the diagram to the side, when the population is graphed against time. So we see on our graph we have population size on our y-axis and time on our x-axis, and we notice a J-shaped curve on our graph. This indicates exponential growth. Exponential growth tends to occur for a short period of time and under a particular set of conditions. For example, when an organism enters a new habitat with an abundance of resources, you can get this exponential growth curve. Exponential growth cannot be sustained in nature because no ecosystem has an unlimited supply of resources such as food. And that wraps up this section. Let's take a short 30-second break to stand and stretch, then we'll learn more about populations. See you soon when you continue on to the next video.